Okay, so suppose you happen to work for Apple and you know that the cost to make an iPhone 7 is $100, say. Whereas the cost to make an iPhone 7 Plus is, say, $300. Now let X and Y be the selling price for the iPhone 7 and the iPhone 7 Plus respectively. So X is the selling price for iPhone 7 and Y is the selling price for iPhone 7 Plus. You're told from your marketing team that demand for the phones obey these equations. So the demand for iPhone 7 depends on how much the price of the iPhone 7 Plus is and the price of the iPhone 7. And also the demand for 7 Plus, same kind of idea. It depends on what the prices for the two phones are. Now this actually kind of makes a little bit of sense because if you look at the first equation here, the demand for iPhone 7, as the price for iPhone 7 Plus goes up, so as Y goes up, the demand for iPhone 7 will also go up because iPhone 7 is now becoming cheaper and cheaper. Whereas if you increase the price of iPhone 7, which is X, you'll see it's got a negative sign here. So as you increase the price of iPhone 7, the demand for iPhone 7 will drop, will go down. Same kind of thing, only in reverse for the demand for 7 Plus. Notice here that if we increase the demand or the price of iPhone 7, which is X, if we increase X, you'll see that the demand for 7 Plus goes up because yes, the price of the iPhone 7 is going up, so the demand for iPhone 7 Plus will go up. Whereas if you increase Y, so you increase the demand for iPhone, or increase the price for iPhone 7 Plus, that will lower the demand for 7 Plus because the price is going up. So the idea is you have these kind of competing prices and you would like to know what price should you sell each of the phones to maximize the profit. So let's go ahead and calculate this. What is the profit? The profit as a function of X and Y will be the demand for iPhone 7, which is 150 plus Y minus 3X. So this is how many phones, iPhone 7s you're going to sell. And how much do you make on each phone? Well, the selling price for iPhone 7 is X, and you're going to subtract off what it costs to make. So you subtract off 100. So this is the profit that you would make from selling iPhone 7s. Now, you want to add the profit that you would make from selling iPhone 7 Plus. So the demand for iPhone 7 Plus is 550 plus 2x minus y times how much per phone are you going to make on the iPhone 7 Plus? It's the cost, or the price of iPhone 7 Plus minus the cost, so y minus 300. So again, this term here is the profit from iPhone 7. So this is how much you're going to make from the selling iPhone 7s. And this part here is going to be the profit from selling, say, iPhone 7 Plus. So the idea is let's figure out an X and a Y that will actually maximize this profit. So let's go ahead and actually expand all of that out and simplify it. Now I'm going to skip that kind of step and skip right to the answer here. If you actually expand all of this out and simplify it, what you end up with is that your profit as a function of X and Y is negative 3x squared plus 3xy minus 150x minus y squared plus 750y minus 180,000. So again, this is nothing more than just foiling these out and collecting all like terms. So pretty simple stuff. And at the end of the day, this is the function of profit as a function of X and Y. So we would like to maximize this. So we would like to figure out its critical points. So let's go ahead and calculate the critical points of this profit function. The critical points, of course, are the locations where the X and Y derivatives are 0. So let's go ahead and calculate the derivative of p with respect to x. So it's negative 6x from this term here plus 3y minus 150. That is the derivative of p with respect to x. The derivative of y with respect to x is derivative of p with respect to y is 3x coming from here minus 2y plus 750. Okay, and to find the critical points, we're going to set those derivatives equal to 0. So the first equation that I'm going to get is negative 6x plus 3y minus 150 equals 0. And the second equation I'm going to get is 3x minus 2y plus 750 equals 0. So now I have two equations and two unknowns, and all I need to do is figure out, solve this for the two unknowns, x and y. So I think I'm going to do a little bit of a clever trick here. What I'm going to do is I'm going to actually multiply all of equation 2 by 2. So I'm just going to rewrite equation 1 here, negative 6x plus 3y minus 150 equals 0. I'm just going to multiply equation 2 by 2, and you'll see why I want to do this. So times 2. What we end up with is 6x minus 4y plus 1,500 equals 0. And the reason I do that is because now I can actually add these two equations together. Negative 6x plus 6x is, of course, 0x. Oops, negative 6x plus 6x is 0x. 3y minus 4y is negative y. Negative 115 plus 1,500 is equal to, say, plus 1,350, and that equals 0. And if I rearrange this, what I end up with is y is equal to 1,350. So there is the price that I would like to sell the iPhone 7 from. So let's put that into either of these equations, so equation 1 or equation 2. I'm going to put it back into equation 2 because it's easier. So we have 3 times x minus 2. I now know what y is. It's 1,350 plus 750 equals 0. So 3x minus, if I simplify this a little bit, this becomes minus 2,700 plus 750 equals 0, which means 3x is equal to 1950. And if I divide both sides by 3, I end up with x is equal to 650. So this is the price that we would like to sell the iPhone 7 for, is $650. Now what we should probably do is actually calculate to see, classify this point to see if it's actually a max or a min or a saddle point. But I think I'll just leave that for now and just point out that this would be the critical point for the profit.